Okay, on page 16C, you can try this on your own and listen to the video when you're done, or you can do it while listening to the video. But if I do 1, 2, and 3 while you're listening, you should try 4, 5, and 6 on your own first and see if you get it right. So for number 1, it says solve and graph each compound inequality. So here, this says x is greater than -1 and less than 3. So greater than -1 and less than 3. So this is where the two would overlap, and they overlap in between -1 and 3. So that's how I'd graph it. My final answer in set builder notation could be x is in between -1 and 3. So all real numbers x such that x is between -1 and 3. This one was pretty simple. Now let's look at number 2. Number 2 says x is less than -1 and x is greater than or equal to 3. So now here's -1, here's 3. So it's greater than or equal to 3 and it's less than -1. Now, and means where do these two overlap? Well, do they overlap? They do not. There is no number that is greater than 3 while simultaneously being less than -1. And is exclusive. And means you have to fulfill both requirements. So this solution is no solution, and the final number line should be empty. Because this is just your work, but you would cross that out and say no solution, and there should be nothing on the final number line. Remember, in and inequalities, it's not unusual to get no solution. Now, number 3, x is less than -1 and x is less than 3. So now I do -1 and 3. If something is less than -1 and if it's less than 3. Now, and means where do these overlap? Well, here, if I draw the line like that, it makes it more obvious to see where they overlap. If it's less than 3, it goes there. If it's less than -1, it starts there. Here, this is where they overlap. Okay, so your final answer would be less than -1 would go this way. So my answer would be all real numbers x such that x is less than -1. Okay? Because and means where they overlap. They only overlap from -1 on. And means they have to fulfill both requirements. Let's think of the number 2. The number 2 is less than 3, but is it also less than -1? No. So it doesn't fulfill both requirements. Let's think of the number -2. Is it less than -1? Yes. Is it less than 3? Yes. So these numbers going in that direction fulfill both requirements. Okay, now try 4, 5, and 6 on your own. Stop the tape and then watch me do them. So, number 4, x is less than -1 or x is greater than 3. So, we have -1, we have 3. Greater than 3 would go that way, less than -1 would go that way. Now this is an OR inequality. We expect OR to look like that. We're not looking for the overlap, we're looking for the union. So your final answer should look just like your work. You could write it this way, or you could write it the way I wrote it up top. In set builder notation, the answer would be x such that x is less than -1 or x is greater than 3. Okay, now number 5. X is greater than or equal to negative 1, or x is less than 3. So I put negative 1, I put 3. Less than 3 goes that way. Greater than or equal to negative 1 goes that way. Now, if this was and, we would just be looking where they overlapped. But it's not and, it's or. So anything that's on one has to be on the final. So that means we have to go all this way and all this way forever. So what ends up happening is the answer will be all real numbers, because there is not a number that is not at least greater than negative 1 or less than 3. Try to think of a number that's not either less than 3 or greater than negative 1. They don't exist. All numbers fulfill these two requirements. So the answer is all real numbers. So where a compound or inequality might be all real numbers, it's very unusual for it to ever be no solution. Where an and inequality would be very unusual to have all real numbers, an and inequality might have no solution. Now, number 6, x is less than negative 1 or x is less than 3. So we have negative 1, we have 3. X is less than 3 or x is less than negative 1. Now, this is where they overlap. So if it was an and, that's what it would be. But it's or, and or doesn't say they have to overlap. Or says if you make it on one, you're on all. So the final answer would be x is less than 3. So all real numbers x such that x is less than 3. So when it's an or, you include everything. You include the most inclusive possibility. Including all those numbers between negative 1 and 3 is inclusive. And is exclusive. They would say, well, exclude those and just include from negative 1 down. This statement is redundant because anything less than negative 3 is automatically less than negative 1. So all we have to say is it just has to be less than negative 3. So remember, if you were to write this on the quiz, you wouldn't get full credit because it shows me you don't understand. Okay, so stop this video.